Okay, for 3-105, it says to calculate the missing side length for each triangle, use the tangent button on your calculator to help. So draw this triangle. And the calculator on your phone has a tangent button. It's just different calculators have different ways of finding the same information. I'm going to use the one that we use in class. I'm going to try to as an example so that you have that as your reference point. That's what you'll have when you're taking a test. But if you find a calculator that you can use at home, just play with it and see what order you're going to put the information in the calculator to get the tangent of the angle. Okay, so we are finding the length of t, and at this point we now know that when you're looking at a slope angle that has a name, the name of that angle, the slope, the change in y over the change in x, is called the tangent ratio. So we now know that our calculator will give us this information if we don't have an eTool or a trig table graphic organizer handy. So I'm going to set this up by saying the slope of 8 degrees, the change in y over the change in x, which is the same as the tangent of 8 degrees, is equal to, so my change in y is t, and my change in x is 82. So I'm going to put t over 82, and I always say put a 1 under the trig ratio just to kind of keep things organized so you know where the numerator is and where the denominator is, and then you're just going to cross multiply. So you're going to get 1 times t. Remember, when you have two ratios, and these are ratios, their cross products are equal. So whatever 1 times t is going to be equal to whatever 82 times tangent of 8 is. And I always put the whole number or the side length that I have in front of the trig ratio so that I don't mix things up when I'm entering it in the calculator. And I'm actually fine with you leaving the answer like this. As you move on with math, you won't be worried so much about the exact answer, but you never know what it's going to be like on PSAT. So let's just type this in. We have 82, and I realize that the lighting is not perfect here. Then I'm going to press tangent 8 degrees. Okay, as this dims down, you're going to see the answer. That's going to take a second. So I'm going to put t is about, and I'm just going to round this off to 11.5. So tangent button gives you the slope, and go ahead and try this with whatever calculator you have at home to see whether you can put tangent and then the angle, or if you need to put the angle and then tangent. If it's just a scientific calculator, then you're probably going to have to put the angle and then press tangent. It's also important that your calculator is in degrees, and I'm going to just check really quickly on this one to make sure it is. Oops. Okay, so see how that says, well, you may not be able to see it. That says angle degrees. That is the segment for now. Okay, part B, we have a 75-degree angle. And remember, if this doesn't look like a slope triangle, this one looked just like a slope triangle, as if I was trying to find the slope of this line, and this is the rise, this was the run. This, not so much, because if this were a slope angle, it would be oriented a different way. So you could still use tracing paper and reorient it, I'll do that for this problem, but I want you to get in the habit of doing it without tracing, because you won't have tracing paper on PSAT. Okay, so if I reoriented it to look like a slope triangle, I would reflect it. And then I would actually, I don't think I would reflect it. I think I would just rotate it. There we go. Now it looks like a slope triangle. And then I would just find the measure of this angle here. So if this is 75, 75 plus 90 plus something equals 180. And you can do this without setting up an equation. You should recognize by now that these two angles are always going to add up to 90 degrees in a right triangle. Because if this is 90, take away 90 from 180, you're left with 90. So if I solve this equation for x, I'm going to get x equals, and I'm just doing 90 minus 25 in my head, and that's going to be 15. So if I reorient it to look like a slope triangle, you could actually just reflect it and say this is the angle that I'm looking at and solve for p that way. Or you could do like I did here and use this angle instead. Either way is correct, and I'll try and show everything right here. But what I was saying is I don't want you to always rely on the tracing paper. Hopefully you figured out in class that if you just look at the side that's across from that angle, that is always your change in y, and that the angle that is, or the side that's next to the angle is always your change in x. So the one that's across from the angle is the opposite. The one that is next to the angle is the adjacent. So so this might be a little bit confusing, but I'm going to start with this setup right here. I'm going to just take after I went through all of that, I'm going to take the triangle and just reflect it and look at this being the change in y and this being the change in x. So that's going to be the slope of 75 degrees, which is the tangent of 75 degrees is going to be my change in y over my change in x. So in this case, that's going to be 12 over p. Then I'm just going to cross multiply. Let's see, I'll just rewrite this over here. Tangent 75 degrees over 1. So I'm going to cross multiply. P times tangent of 75 degrees would just be p times tangent 75 degrees. Now a lot of you are going to be tempted to put this in the calculator right now. I'm not going to say you can't, but I would say wait until the end of a problem to use your calculator to avoid rounding errors or issues with rounding. Okay, and then 12 times 1 is 12. I'm solving for p, so I need to get p by itself. So I'm going to undo this multiplication. P is being multiplied by tangent of 75. The opposite of multiplication is division. So I'm dividing both sides by tangent of 75 degrees. So these cancel out, and this would be my final answer, which I'm actually fine with you leaving it like this. Let's go ahead and use the calculator just in case. Let's see, 12 divided by tangent 75. Oh, look at that. That showed up really nicely. So about 3.21 is what I got. Just check and make sure I have the right answer on these. Yeah. Okay. Now, you might have reoriented your triangle and set it up so that the slope angle that you were looking at was 15 degrees. I'm going to show you what that would have given you if I had used Let me just quickly draw that on here. If instead I had focused on 15 degrees as my reference angle, okay, 12 is right here, P is right here, I would set that up by saying the slope of 15 degrees, which is the tangent of 15 degrees, the change in y over the change in x. Here, the change in y would be P, and the change in x would be 12. So then P over 12 would give me tangent of 15 degrees over 1. When I cross multiply here, I get 1 times P is P, and then 12 times tangent of 15 degrees would be my answer. So let's see what 12 times tangent of 15 degrees is. Same exact answer we got when we solved the other way. So that fits with what we noticed on our trig table graphic organizer, that if you are looking at complementary angles, if you're looking at 11 and 79, for example, the slopes are reciprocals. So here we were looking at 75. The slope of 75 is the reciprocal of the slope of 15. So you can set it up based on either angle and still get the right answer, as long as it's set up correctly. Okay, for part C, let's try to do this without reorienting the triangle. Let's look at 68. Actually, this one's on our trig table graphic organizer. If I look at the side that's across from opposite 68, this side must be the change in y. If you're still having trouble visualizing that, take some tracing paper. Okay, I'm going to just rotate it because I'm going to use 68. And do you see that this would be change in y, this would be change in x. Without reorienting it, I just look at the side that's across from the angle. That's the change in y. So the slope of 68, which is the tangent of 68, is equal to the change in y over the change in x. So that's going to be b over 60. Let's put a 1 under tangent 68. Let's cross multiply, and that gives us b equals 60 times tangent 68 degrees, which is 148.5. Okay, for 3-106, it says to write the equation of the line that has a slope angle of 25 degrees and a y-intercept of 0,4 and sketch a graph of this line. Assume the slope of the line is positive. Okay, so we know that the slope is the same as the tangent. So a slope of 25 degrees would be, kind of not too steep. And we're assuming that the slope is positive. It's going uphill. So the slope is positive, and we know that the slope of 25 is equal to the tangent of 25 degrees. Okay, and we know the y-intercept is 0,4. So remember, when you're writing an equation and you have the slope and you have the y-intercept, you can just use slope-intercept form. Put your slope in here. Now I'm not going to put that in the calculator yet. I'm just going to put tangent 25 degrees for my slope, which looks a little weird, but that is the slope of 25 degrees, times x plus, my y-intercept is 4. Remember, b is your y-intercept. There's your equation. And it says to sketch a graph of this line. So I need to find, okay, I have to find my protractor. Okay, so let's sketch this graph. Give yourself a little room because your y-intercept is 4, and then you're going uphill, so don't do this at the very top of the paper. You may want to look at what it's going to look like before you actually start placing it on your paper. Okay, y-intercept is 4. 1, 2, 3, 4. And your slope is 25 degrees. So I'm just going to use my protractor, which I'm realizing you might not have a protractor at home. So I'll tell you what I get for the slope approximately. Let's see, 25 would be right here between 20 and 30. So I'm going to put a little mark right there, and I'm going to connect that mark and this y-intercept. And I might use my ruler instead of my protractor. Okay, so that slope is, let's see, what is that slope? I'm going to do tangent 25 degrees. Okay, it's almost 0.5, so it's almost 1/2. So it's approximately up 1/2, but it's not exactly 1/2, so you really can't use that as a guideline. So let's see if I can just find another point that you could use. Maybe this over here. You know, you could just do an approximate slope for your graph, since you may or may not have a protractor at home. So this is y equals tangent 25 degrees x plus 4, and we can just leave it at that. Okay, for 107, are you becoming familiar with these diamond problems? I know we had a stretch where we weren't doing paper and pencil homework, so I hope this is going to be enough practice. It is going to be chapter 4, something you will be using all the time. So we are finding the missing pieces, and remember, this is x, this is the product. This is the sum. So I'm looking for another number that I can multiply by 5 to get negative 25. Well, that's got to be negative 5. And then when I add negative 5 and 5, I get 0. Okay, let's multiply 8 times negative 2. And let's add 8 and negative 2. Product, sum. You might need to pause the video to draw all of your diamonds as you go along or before you start. So here we're trying to figure out, what can I add? Remember, this is x plus y. What can I add to 6 to get 9? Well, that's easy, 3. And then 3 times 6 is 18. That's your product. Okay, this is my product. This is my sum. So what can I multiply to get negative 20? But when I add, I get 19. Now, a lot of people are going to say, oh, 4 times 5 is 20. That's true. And one of those would have to be negative, but is there any way to add a 4 and 5 together and get 19? So it's not 4 and 5. So think about other factors of 20. 10 and 2, that will multiply to give you 20. But is there any way to add those two, one of them being negative, and get positive 19? No. So the other factors of 20 would be 20 and 1. So it's got to be 20 and 1. And we just need to figure out which one would have to be negative in order to add these two together and get a positive 20. Well, positive 20 and negative 1 is positive 19. Positive 20 times negative 1 is negative 20. So that's what you're going to be doing in chapter 4. You're going to be finding the missing missing factors given a sum, and you'll get better and better at it, and this is to prepare you for that. Okay, 3108 says to calculate the expected value. We haven't done this yet. We may not get to it, or if we do, it'll be really fast, so this might be the only practice you get with it. And it's not really on the test or PSAT. Just good to know. Will come up later. So expected value for this game with this spinner would be the value of that piece on the spinner. So 10 times how many times you're expected to land on that part of the spinner, which would be 90 over 360. That if this is 90 right here, this must be 90 right here. Okay, plus negative 3, or I could just say minus 3 times 90 over 360, plus 6 times, this is half a circle, so 6 times 180 over 360. And you could type all of that in the calculator at once. Oh, let me just put minus. Oops. Okay, so I'm going to change that to a decimal. So the expected value of this game is 4.75. So you would probably win some money if you were playing using that spinner. Okay, 109, you should be comfortable with these. We've done a lot of con on these, and we've done a lot of paper and pencil. So there's definitely some like this on your next test. Remember, if the picture doesn't do it, you can always extend the line, and you know when you have intersecting lines, you have 360 degrees. And if you're just looking at this angle and this angle, that's a half a circle. That's 180. Yes, you do need to draw these diagrams. So my equation would be 4x minus 3 plus 3x plus 1 equals 180. Combine like terms. 4x and 3x would be 7x. Negative 3 and positive 1 would be negative 2. Solve for x. Add 2 to both sides. Divide by 7. X is 26. We are supposed to state the relationship here. You could say half circle equals 180. Technically, we should say supplementary angles. These are supplementary angles. You could say this is a linear pair. Okay, draw the next picture for B. We have parallel lines, and we have the arrows to show that they're parallel, which means that these 4 angles here are going to match these 4 angles here. Now, as for this angle and this angle, I'm going to use the tracing paper to see. You can always use tracing paper on the test if you need to. Okay, I'm going to trace this angle and translate it so that the vertex lines up with the vertex at this angle. And I notice that these 2 angles form vertical angles. You could always rotate it 180 degrees. These 2 angles are going to be the same. They are equal. They're called alternate exterior angles. You could put vertical angles. Let's put in parentheses alternate exterior angles, and they're equal. So then my equation would be 5x plus 6 equals 2x plus 21. There are x's on both sides. There's 4 things you can do. I recommend you get rid of the smaller one. Minus 2x on both sides. So 3x plus 6 equals 21. Subtract 6 from both sides. Divide by 3. So x equals 5. Okay, here we have a triangle, and we know that all the angles in a triangle sum to 180. So my equation is going to be that this angle plus this angle plus this angle equals 180. So I'm going to go ahead and combine like terms before I write the equation. 4x plus 3x plus 1x is 8x. Positive 28 plus 19, let's see, that would be 47, plus 13 would be 60. So I just combined like terms, equals 180. Solve for x, subtract 60 from each side, divide both sides by 8, x equals 15. Okay, so check and make sure I did these right. All right, last one is something we haven't used a whole lot. You don't have to use this relationship. You can do it the long way, but this is, we saw this in a homework from chapter 1, I think. This is called an exterior, and it was also in the checkpoint for checkpoint 3. And the exterior angle equals the sum of the remote interior angles. This angle on the outside is equal to these two angles right here. Do you have to do it this way? No. Is it shorter? Yes. So you could find this missing angle by using these two angles and then do the fact that these make a half circle. That's fine. This is just a little bit faster, I think. So I'm going to say that 4x minus 10, whoops, my exterior angle is equal to 40 plus 90, the sum of these two angles together. So that's going to give me, let's go ahead and combine like terms, 130 equals 4x minus 10. Add 10 to both sides. Divide both sides by 4. And that would reduce to 70 over 2 to 35. Okay, 3-110. Rakisha is puzzled. She is working with the parallelogram drawn at right, and she wants to make it smaller instead of bigger. What should she do if she wants the sides of her new figure to be half as long as the original sides? What scale factor should she use, and what are the dimensions of her new figure? Well, if she wants them to be half as long, then her scale factor should be 1/2. She's just going to multiply the sides by 1/2. So if we multiply, the picture looked like this. Let's just go ahead and draw this really quickly. So then she would do 11 times 1/2, which is the same as doing 11 divided by 2. So the new length here would be 5.5, and then 16 times 1/2 would be same as 16 divided by 2, 8. So the dimensions of the new parallelogram would be 5.5 and 8. While drawing some other shapes, Rakisha ended up with a shape congruent to the original parallelogram. What is the ratio between the pairs of corresponding sides? Well, this may seem like a trick question. she wound up with a shape congruent, so then the ratio would be 1 to 1. If you get a shape that's identical, then if you compare the sides, you're just multiplying by 1. So 1 to 1 would be the ratio for congruent figures. Okay, part C. Rakisha is convinced that every parallelogram with adjacent sides, adjacent just means next to, that measure 11 and 16 units will be congruent to the parallelogram above. Is she correct? Justify your answer using a proof or a counterexample. Well, just because you have sides that are 11 and 16, that doesn't mean it's going to look exactly like this. The angle here may be different. So you could have, and by definition, a rectangle is a parallelogram. You could have a rectangle with sides 11 and 16. Here's a counterexample right here. When you come up with one example that refutes your statement, that's called a counterexample. Okay, that's it for today.